Alright, so section 3.5, we're talking about symmetry. First one I'm going to talk about is reflectional symmetry. That's what we were just talking about with the line of reflection. Okay? With reflectional symmetry, it is when you have a line, what we've been calling line of reflection. Okay, that can also be called the line of symmetry. Okay, line of symmetry and line of reflection are the same thing. Okay, so if I look at this figure here, I have a line of reflection or line of symmetry here because if I fold one side onto the other side, it would be the same thing. Okay, same thing here. If I fold it over that line, it would still be the same. So that shape has two different lines of symmetry. Okay, that's called reflectional symmetry. This one down here, rotational symmetry. Okay, what does rotate mean? It's like turning, right? Okay, this point right here, if I'm turning along this point, the rotational symmetry is if I can map it onto itself. Now, hang on. They said it has to be a rotation less than 360. Why do you think that's the case? Right, so 360, that'd be a whole full circle. That does not count as rotational symmetry. Okay, it is not rotational symmetry because 360 just gets it back to what it was. Okay, so it has to be less than 360 degrees. So here, if I technically flip this over 180 degrees, is that still the same shape? Yes, so that has rotational symmetry. Okay, so reflectional symmetry is where if you fold it over a line, it's the same. Rotational symmetry has to be less than 360 to get the same image. Capiche? All right, go ahead and try number 1, A and B, with someone sitting next to you. Let's start with reflectional. Does 1A have reflectional symmetry?
Yes.
Yes. How many lines of symmetry did you come up with?
Well, you can actually get
Okay, see this one? Does everyone agree with that one?
Yeah.
Okay, this horizontal line? Yeah, so I agree we have 2. I saw some of us say we have more than 2. Okay, why can I not do the diagonal? Right, if it folds over, the vertices or these angles are not going to match up. That's just like if I tried to fold this piece of paper diagonally, it would not match up. That's what would happen to that. Okay, so how many lines of reflection does A have? 2 lines of reflection. So 2 reflectional symmetries. What about rotational symmetry? Remember, rotational symmetry means however much you rotate it, it still looks like this image. Does it have rotational symmetry? How many degrees? It would have to be 180. Why could I not say 90?
because it'd be half.
It would be side, right? Okay. Even though it's still the same shape when it's flipped 90 degrees, okay, it wants it to be the same orientation on the rotations. Okay, so this does have rotational symmetry. Can't spell. Yes, it does have rotational at 180 degrees. Okay. Questions about that one? All right, part B. How many lines of reflection, or does it have reflectional symmetry?
No.
Why not?
The arrows would be.
Right. So I had a good question. They asked if the image on the inside matters. Yes, it does matter. Okay. If we just had the diamond shape, would that have symmetry? Yes, but we have to pay attention to what's on the inside. If I folded that in half, what would not match up? The arrows would match up. Okay. Same argument here. If I folded that in half, the arrows would not match up. Okay. So no reflectional symmetry. What about rotational symmetry? Is there a way I can rotate that to make it look like itself? 180, right? Yep, so yes, rotational, 180 degrees. Okay, if you're having trouble visualizing this stuff, literally take your paper, turn it 180 degrees. Is it the same image? Yes. Okay. I want to look at this one here, not on your paper. Regular. If it says a regular hexagon, first of all, how many sides does a hexagon have? 6. What does it mean by regular?
And unchanged.
What'd you say?
It's like the pre.
Okay, think of just a regular shape.
Square.
Okay, what would a regular hexagon be? What does the term regular mean?
It's like the pre.
What do you think normal?
What
do we know about all the sides? All the sides are the same. So in a regular polygon, all sides are the same. Okay, so keep that in mind when we're doing this one. When we're talking about regular polygons and their lines of symmetry, okay, we get those lines of symmetry from going from vertice to vertice. Does everyone know what a vertice is? It's where that angle is, okay? So if I go from vertice to opposite vertice, that is a line of reflection, okay, or a line of symmetry, okay? Understand there's multiple of those in a regular hexagon. Okay, so how many lines of symmetry did I have in this one? 3. Okay, there are also lines of symmetry when you're going from a midpoint. What's a midpoint? Middle of a side, right? You're also going from a middle of a side to another middle of a side. Well, how many different lines of symmetry do I have here? 3. So how many in total does the hexagon have?
3.
Has 6 in total. Well, what do you understand the relationship here? 6 sides, it has 6 lines of symmetry. Okay, that's the same for any regular polygon. Okay, so how many does a pentagon have? 5. How many does a square have? 4. How many does the octagon have? 8. So it's the same if it is regular. Again, what does regular mean?
Same sign.
All sides are the same length. Yep. Go ahead and try 2A and B. You're telling me the same thing. You're telling me, does it have reflectional symmetry and does it have rotational symmetry? Example 2A. First of all, what shape is that? Rectangle. Can I call that a regular rectangle?
No.
Why not? All sides are not the same. Okay, so a rectangle is not regular. Capiche? Okay. Let's start with reflectional. How many lines of symmetry can I draw? I agree. I have one here and one here. Why can I not draw this diagonal line from vertice to vertice? If you flip it, they won't match up, and it's not regular, so the diagonals would not work. Okay? So I have 2 reflectional symmetries. What was the next one we had to check? Rotational. Do I have any rotational symmetry? How many? 180 degrees rotational. Yep. Good. What about 2B? 1 reflection. Where? Down the middle. Why can I not count this horizontal line? Right. There are different side lengths up here. Those would not match up if I folded it over. Good. So it has 1 reflectional symmetry. What about rotational? What about 360? Right. Has to be less than 360. Okay, remember that. 360 cannot count when you're talking about rotational symmetry. Capiche? So this one has no rotational symmetry. All right. One more thing to talk about over there, and that's called point symmetry. Okay? Point symmetry is if I put a point in the middle of our figure that we're trying to determine symmetry on. If I can flip that figure basically upside down, 180 degrees, if I have 180 degree rotational symmetry, then I have point symmetry. Okay? Write on your notes somewhere. Point symmetry equals 180 degree rotational. Okay, so again, point symmetry is if I can put a point in the middle of the image and I just flip it upside down 180 degrees. If it's the same, then it has point symmetry. Okay, so point symmetry and 180 degree rotational symmetry is the same thing. Okay, they just put a name to it because 180 is the most common symmetry. Okay, questions on point symmetry? Try 3A, B, C, and D. You're going through all 3 of those options. Okay, talking about reflectional symmetry, rotational symmetry, and point symmetry. On 3A, let's go through all 3 of those. Reflectional. How many?
4.
I hear 4. Okay, I have one here. One here. Where'd you get the other 2? Diagonals. Yep, so this one has 4 reflectional. What about rotational? Can I rotate it and it still be the same? Yes. Is it point symmetry? Yes. Again, what does point symmetry mean? Can rotate 180 degrees. So yes, that is point symmetry. Okay. Someone had a really good question. if it doesn't go like a specific 90 degrees or specific 180 or 270. Okay? I'm not going to be picky about how many degrees it goes. Okay? Not going to be picky about that. The only one I'm going to be picky about is the 180. Okay? So don't worry about telling me how many specific degrees it is. If you don't know, just put yes, it's rotational. Okay? But I do need to know if it's point symmetry, which is the 180. Okay? Number 3B. How many reflectional?
2.
Does everyone agree with 2?
Yeah.
2 reflectional. Yep, it has that horizontal line and it has that vertical line. What about rotational? Yes. Does it have point symmetry? Yes, because 180 degrees. Yep. What about 3C? Does everyone agree with 4? 4 reflectional? Okay. Again, with images like this, does the inside matter? What the inside looks like? Yes. The image on the inside does matter. What about rotational? Yes. Does anyone know the specific degrees? 90. What else? 180. What else? Yep. So does this have point symmetry? Yes. It has 180 degree rotational, so that does mean it has point symmetry. That last one, kind of tricky. Does it have reflectional symmetry? If I draw in a vertical line here, what throws it off? The arrows throw it off, right? So this has no reflectional symmetry. Does it have rotational symmetry? Yes. How many degrees? It's like 120 and 240. Who said that? Good job. Yeah, like I said, I'm not going to be picky about this. Okay? You don't need to know that specifically. Okay? Does it have rotational symmetry? Sorry, point symmetry. What does point symmetry mean? 180. If you flip your paper upside down, is it the same image? No. So no point symmetry. On example 4, what classifies a square to be a square? All sides are the same. Kind of. That looked like a rectangle. What can this be called? Regular. Yes. Regular is all sides are the same. So let's go through the 3 options. Reflectional. Does it have reflectional symmetry? Yes. How many? 4. Why can we have the diagonal now? Because all sides are the same. It's regular. Okay, so we have 4 reflectional. Good. What about rotational? Yes. How much? 90, 180, 270. Why can we not say 360? Has to be less than 360. Yep. Does it have point symmetry? Yes. Why? Because it has 180 degrees. Good. Flip all the way to the back of your notes. We're going to talk about the left side here. How can you tell whether a figure is symmetric? How have we been describing it? If something matches up, right? And we talked about like reflectional, rotational, and point, right? Okay. What is the error that Adam did in number 2?
Oh, it can't go horizontal.
Right. Do not go home and try to bend a light bulb in half. Okay. Number 3, what type of symmetry does a figure have if it can be mapped onto itself by being flipped over a line? Reflectional. What was the dead giveaway? Flipped over a line. Yep. I'm skipping number 4. Number 5, is it possible for a figure to have rotational symmetry and no reflectional symmetry? Is it possible? Yes, there was an example that we did. Which example had rotational but no reflectional? The recycling symbol, right? Yep, so that is possible. It can happen. Okay? Number 6 through 11, I want you to do that with someone sitting next to you. Make sure you read the directions of what it actually wants you to do. Go. 6 through 11. 6, it says, how many lines of symmetry does each figure have? Number 6. Does everyone agree with 2?
Yes.
What about number 2?
1.
Or number 7? 1. Why can I not do this?
Because it's uneven.
Right. It would, if I flipped it over that line, it would not be the same. What about 8 and 9? It wants rotational symmetry, and if it has point symmetry. Number 8, does it have rotational symmetry? Yes. Does it have point symmetry? What does point symmetry mean? 180 degrees. Yep. What about number 9? Does it have rotational symmetry? Yes. Does anyone take a shot about how many degrees? It's 120. Yep. What about point symmetry? No. Last 2. Number 10. We're going through all 3 of those. Reflectional. Yes or no? Where? Does anyone know what this shape is called? A kite. Yep. Can I do this way? No. So it has one line of reflection. What about rotational symmetry? No. So if it doesn't have rotational symmetry, can it have point symmetry? No. All right, last one, number 11. Did anyone find a trick to this one?
Yeah, 8 sides.
Has 8 sides. Why does that matter to us? Because it's regular, right? All of these sides are the same. So we have 8 sides. How many lines of reflection do we have? 8. Does it have rotational symmetry? Yes. Does it have point symmetry? Yes. Good.